In this video, we're going to look mostly at applications of triangle trigonometry. And again, not necessarily right triangles. We may need to use the law of sines or the law of cosines. Before we start, we want to talk about a system of measurement called a bearing. And this is a navigational term. So a bearing is used to specify the location of one point relative to another, okay? And we're going to use the compass direction, north, east, south, west. So the bearing from point O, which we're using O because we're calling that kind of the origin. That's the intersection of the north-south and the east-west line. The bearing from point O to point P is always an acute angle measured in degrees between that ray from O to P and the north-south line. So we always measure. It does not matter where we are on this four-directional compass here. So we always measure the angle from the ray to the north-south line, okay? So we would not go this way because that would go to the east-west line. Over here, same thing. Here's our ray. We measure from the north-south line, we get 65 degrees. The direction as far as clockwise, counterclockwise doesn't really matter here because that's what the east and west and the north and south are going to tell us to do, okay? Now, a bearing has three parts. It's either going to have an N or an S, which tells us do we go up for north or down for south. And we always go in this order. So first we're going to decide north or south. Then it's going to give us the measure of an acute angle, and then it's going to give us east or west, which tells us which direction to measure from the north-south line, okay? So let's look at a couple of examples. Here's this picture that's got a lot of stuff on it. First, we want to find the bearing from O to B. So we're starting here in the center, and we're going to B. That's this ray right here. So we know it's going to be 40 degrees. We know that this is going to be north because we are on the north side of the north-south line. And then our angle from the north-south line is pointing towards the west. So the way that we would name this is that we would say north 40 degrees west. Okay. Dogs are everywhere tonight. Okay, so similarly then, if we want the bearing from O to A, here's what's sneaky about this. So O to A is this ray right here. Now, don't get tricked by the fact that they marked this 20-degree angle. Now, we're going to need that, but remember that to find the bearing from O to A, we again went to the north. The angle that we need is this one right here because it always has to be measured from the north-south line. Now, we know that north and south and east and west are perpendicular, so we know this is a right angle, which means this angle here has to be 70 degrees. So that's why we need the 20, but the answer for the bearing, we have to use that top angle there. So this is going to be north 70 degrees east, okay? Now you do have to remember the compass directions. I always learned never eat shredded wheat. You may have learned never enter Santa's workshop. You may have learned never eat slimy worms or soggy waffles. Or there's a zillion different ways to remember, but you do need to remember your compass directions. Pause the video and see if you can come up with the bearing from O to D and the bearing from O to C, examples 3 and 4. Here's what you should get. Both of them this time were on the south side of the north-south line. And then again, for number 4, you have to use the complement of that angle, subtract it from 90, because it always has to be the angle between the north-south line and the ray that you are creating. Okay, so that's how we read a bearing. So what we're going to focus on today is looking at application style problems. They might give you bearings, they might not give you bearings, they might just give you information, but we have 3 different things that we can do. The first one is we can use our SOHCAHTOA trig ratios, sine, cosine, and tangent. That only applies to right triangles. So if that doesn't work, then we have to fall to one of our other 2 things. The first option is your law of sines. Now, this is for not right triangles, oblique triangles. And again, in order to use the law of sines, you need a complete pair, meaning you need to know the angle and the opposite side. Side A, angle A, side B, angle B, whatever. But you need a complete pair. If the law of sines doesn't work, then we can remember to use our law of cosines. Remember that you'll only ever have to use the law of cosines one time, then you go back to the law of sines, okay? So let's look at this first example. It says, a boat leaves the entrance to a harbor and travels 25 miles on a bearing of north 42 degrees east. Now, they've already marked that on the picture for us. As the figure shows, he then turns the boat 90 degrees clockwise and travels 18 miles on a bearing of south 48 degrees. Okay, now they gave us the picture, which was very nice, but here's what's important when you're trying to come up with a picture using the bearing directions. At every point where you change directions, you need a new north-south line. So that's why we have this drawn here multiple times, okay? So this was our starting position. I'm going to call that A. That was our first spot. So they went north 42 degrees. That's where this line comes from, okay? And they followed this line until they got to this point. Let's call that B. Excuse me. They turned the boat 90 degrees, which is why we know that that is a right angle. And they went at a bearing this time of south. So we need our north-south line there. So they went below the dot B, 48 degrees, and that's how we get to there. And so the boat has ended up here at C. So we have a couple questions. First, how far is the boat to the nearest tenth of a mile from the harbor entrance? So that's asking us about the distance from the boat back to where it started. So that is a C. Well, since this is a right triangle, we can just use our trig ratios. So I know that this is a right angle. Let's see, what else do we know here? And here's where some of your geometry is going to have to come back. This angle right here is also 42 degrees. Now, how do I know that? Because those two north-south lines are parallel. They have to be. And so those are, if you remember from geometry, that is a pair of alternate interior angles, which are congruent. So we know that that is going to be 42 right there. You could also figure that out by knowing that you have a right angle there at the corner. So there's multiple ways that you could figure that out. So that's kind of all the information we know in terms of angles. But we do have, if we kind of take away some of the noise here and look just at what we're looking at, we have a right triangle like this. We know that this is 25 and this is 18. If I want to know this distance, that's just the Pythagorean theorem. So A is going to be, these are the two legs, x is the hypotenuse. So 18 squared plus 25 squared equals x squared. They said to the nearest tenth of a mile. So we want to add those together and take the square root. So we're going to get the square root of 18 squared plus 25 squared, which is 30.8 when we round to the nearest tenth of a mile. And those are our units. All right, now for part B, the question is, what is the bearing to the nearest tenth of a degree of the boat from the harbor entrance? So our starting point has to be the harbor entrance. We said that was A, and we're going to the boat, which again, we were calling C. Okay, so we want the bearing from A to C. Now, again, we have to imagine kind of here's where our east-west line is. We already had this first bearing was 42. The bearing now that we want is all the way to here. So that's why we're going to need to figure out what theta is so that we can add it to the 42. So if we come back to our sketch of the right triangle, here's theta right here. Well, we can solve for theta using tangent. So we know that the tangent of theta is equal to opposite over adjacent. And so to solve for theta, we need to do the tangent inverse of 18 divided by 25. And so we put that into our calculator, and we should get 35.8 degrees. That's theta. So now to figure out the bearing, we need to add 42 to that, and that gives us 77.8 degrees. So the bearing is north 77.8 degrees east, because we're going to the east. Okay? So that's how that works. Now, number 6. They give us a lot of details, but they were very kind in giving you the picture here. So we have 2 fire lookout stations that are 20 miles apart, with station B directly east of station A. So that horizontal line at the bottom is the east-west line. Both stations spot a fire on a mountain to the north. The bearing from station A to the fire is north 50 degrees east. So again, this dotted line here represents the north-south line. So this is north, south is down here. So that's where the 50 comes from. Now, north-south is always perpendicular to east-west. So we know that that's a right angle, which is how we know that the other angle inside the triangle is 40 degrees. Then it gives us the bearing for station B, which again is labeled on the picture, and they found the complement for you. How far to the nearest tenth of a mile is the fire from station A? So we are trying to solve for B. That's the length that we want. Now, the question is, what do we know? Can I use the law of cosines? Well, if I do, I need a complete pair. The only side I know is C. So that means I either need to know or be able to figure out what angle C is. And we can, because we know the 40 and the 54, then we can determine by subtracting from 180 that angle C is 86 degrees. Now we have a complete pair. We know angle C and we know side C. So we can set up our law of sines. We know that 20 over the sine of 86 degrees is equal to B, which is what we're trying to find, over the sine of 54 degrees. So B, when we cross multiply, 20 sine 54 divided by sine 86, we are just going to put that into our calculator and go ahead and do that and see what you get. I get 16.2 miles when I plug that in. It did ask us to round to the nearest tenth, and that's it for this one. That's all it's asking us for, is how far the fire station A is from the fire, which is 16.2 miles. Okay? Last example for today. So this one says 2 airplanes leave an airport at the same time on different runways. One flies a bearing of north 66 degrees west at 320 miles per hour. The other airplane flies on a bearing of south 26 degrees west at 300 miles per hour. How far apart will the airplanes be after 2 hours? So again, I think they give you too much information on these pictures. Like, you should be able to figure a lot of this out. They're being very generous to you by providing these pictures. So where did the 650 miles and the 600 miles come from? Because that was not something specifically that was mentioned. So if you remember, they told us 325 miles per hour. That means that in 1 hour, they can go 325 miles. So in 2 hours, they can go 650 miles, okay? So you multiply the rate, miles per hour, times the time, number of hours, and that's going to give you that. Remember, distance is equal to rate times time. So that's how we're getting A and C, is multiplying the rate of that airplane times the 2 hours, okay? Now, again, if we were trying to draw this picture, we're imagining here's the east-west line through here. So north 66 degrees west is the first airplane A. And then south 26 degrees west is airplane B. How far apart are the planes? So B, the side length, is what we're trying to figure out. Okay, now I know 2 of the sides. I do not know the third. This is not a right triangle, so we cannot use the Pythagorean theorem. So that means that in order to figure out what B is, I need this to be a side angle side kind of triangle because we can't figure out the third side without it. In order to use the law of cosines, I need to know this angle here. Well, again, based on knowing what this east-west line is, we know that if that top angle is 66, this is a right angle, so subtract it from 90 and we get 24. And the bottom one, we have 26, subtract that from 90 and we get 64 degrees. So angle B is the sum of those, which is going to be 88 degrees. So that is angle B. So if we come over here and make ourselves kind of a small sketch that's a little less cluttered, that's what I like to do. So we have 88 degrees, we have 600 miles, and we have 650 miles. And this is, let's see, C, B, A. We need to build our law of cosines formula around angle B and side B. So that's going to be B squared equals A squared plus B squared minus 2, sorry, not B squared, C squared. C is the side we haven't used yet. We used B over here, so A and C have to be these two. Minus 2AC cosine of angle B, because again, we always bookend B at the beginning, B at the end, side and angle. So see if you can finish this one out. We've practiced the law of cosines. Pause your video, plug in the numbers, solve for B, and come back when you got it. All right, here is what I get. When you plug all those in, then you got to take the square root. Remember, we don't need a plus or minus because we're talking about distance. So you're only going to look at the positive value of the square root. It didn't tell us how to round on this one, so I went ahead and did to the 10th like the other problems. I got 869.1 miles. So on your math lab, you're going to have some things described in bearings, some things that are just information, not necessarily bearings, directions. You might have to draw some of the pictures. You might be given the pictures. Some of them are going to be right triangles. That's your SOHCAHTOA. Some of them are not. So the trickiest part is deciding on your strategy. And that is what you'll need to do on this homework assignment.